Hey, good morning, all. Welcome to the Common Good Podcast. It's Thursday, January 5th, or as they say around the United States now, Insurrection Eve. So happy Insurrection Eve. And how you guys going to spend the night tonight? You remember
I'm actually
back
going to
to
walk around my house 7 times, blowing a shofar.
There you go.
Yeah, boy, I bet Lauren Boebert and those cats are really busy today, getting all their stuff out. You know, pulling out the old pictures, pulling out the body armor to hang on their fireplace and really brag about what they accomplished. Remember when the former failed president and steak salesman said, "We will remember this day forever." That's the kind of thing he did. Yeah. So we'll just pre-Eve that thing. Well, often we talk about the good things that politics brings to us in this world, but on Thursdays, at least every other week, we get to talk about what's going on up in the skies with astrophysicist, pastor, professor, birder, Paul Wallace. So, Paul, good to see you. Paul's outside of Decatur, Georgia. Yep. And Paul, how's the weather down there? This is about the time of year you all get to brag.
It's pretty nice. We had a actual freeze a couple last week. Mm-hmm. We had, when the whole country got cold. Yep. We got down into the single digits, which is really unusual here. Yeah. We got down to like 8 one night. Man. Which is super unusual. But I grew up here in the Atlanta metro area, and I seem to remember back when I was a kid and even a teenager back in the 80s, it wasn't that unusual to get into the single digits. Huh. I think I remember it happening several times. Yeah. I remember us having to run our pipes at night, and I remember, I used to work for Chick-fil-A. I'd go out to meet the truck at 5 a.m. And one time we went and it was 0.
Wow.
But, I seem to remember it happening more. I don't know. It's just an old guy story. I don't know. But
back in my day.
Yeah. But right now it's probably about 40 degrees, 42 degrees, and it's partly cloudy. Kind of nice, actually.
Yeah, it's going to warm up, probably be 55, 56, something like that. People are going to be out with a vest on, just a vest, no sleeves, just keeping the core warm.
Yeah.
Still, the vest is the most curious, winter garment that I know of. Are you a vest wearer? I know a lot of people wear those things. Just the vest. They have a shirt on sometimes.
The poofy vests.
Yeah. Like sometimes they're poofy. Vests. Sometimes they're made out of that terry cloth like material.
No, I'm not a vest guy. No. Yeah, I'm a hoodie guy. Like when I'm wearing.
But you live you sure are. You live in a place where the vest is like the perfect winter gear. Like, hey, dress for the weather and only put on half a jacket.
I feel like I need the opposite of a vest because my core is plenty warm, but the limbs get cold.
Yeah, arms
just want
get cold.
Sleeves.
Just sleeves.
Maybe long-sleeved gloves. Just go up past the elbow.
Dan, I don't know if these were still around when you were junior hire, but I think when Paul and I were junior hires, I think this would be true of you too, Paul, they sold shirts that were, I think they were called a Dickie, which I just don't think you could sell a shirt with that name anymore. But it was like a flannel.
Yeah.
But it had a built-in turtleneck. Do you remember these?
Oh, yeah. Yeah.
But the turtleneck was just sewn in.
Right.
Yeah.
So other material looking like you had a turtleneck on and then put a shirt over it.
I don't remember the name, but I do remember the shirt. Yeah.
I distinctly remember the name. Yeah. It was for sure Dickie. Yeah.
It is. It's Dickie. Which now that I'm older, I'm like, I can see now why they call it that. Cause just such a Dickie for wearing that. That was something that, that like you should look for somehow, like a shirt, but then it has extra sleeves. So, over it, sort of a Dickie for your arms.
Yeah.
Well, hey, where I live, I heard on the report this morning that in the last, 48 hours, something like that, 15 inches of snow we have gotten.
Really?
And it has just been coming almost nonstop, or little waves of, nonstop waves of wintry problem out here. It is so high I cannot see around the end of my driveway standing up. And I'm 6'7" and I can't see around the driveway. Yeah, it's like we live in upstate New York. It's
So
really.
how deep is it? I mean, are you telling me it's 6 feet deep?
Well, it is at the end of the driveway where you have to push your snow up or shovel it or snow blow it.
Yeah,
They kind of push the snow down, and anyway,
that just defies my
those
imagination.
peaks at the bottom.
Yeah,
really, really something.
Wow.
How about there in Michigan, Dan? What do you got? What do you got?
Nothing. It's just
Is it
kind of
brown, or you got
cold
snow on
and
the
wet.
ground?
No
Oh,
snow.
do you have
Yeah.
no snow on the ground?
I
How
thought maybe
about
we'd be getting it from you by this time, but nothing.
I think the atmospheric rivers have run out of their moisture by the time they get there. That's the phrase I heard that I heard going on in California. Atmospheric rivers.
That's a good phrase. That's a good phrase.
Yeah.
Let's just chill out though with all the new lingo. Weather
and they call it. Dan's totally got the old man syndrome when it comes to names for weather.
We had a bomb cyclone and
they call it the bomb cyclone.
Dan is saturated. Dan, where in Michigan are you?
The southwest corner, so right on Lake Michigan.
Okay.
Yeah, where there should be a lot of snow.
Yeah.
Lake effect and all that.
You would think.
Yeah.
But thinking of our friends out in California, I know, at some point we have a lot of people that will hop on this, either watching live or the recording, who are from California, and they're really experiencing it out there. I mean, the weather is a major issue. They had a drought for years. I think almost a decade of a drought, something like that. And now they're just getting pummeled by the atmospheric rivers and the bomb cyclones of the weather. Which I will say, I know we're going to talk about a little higher than that atmospheric river. That phrase does put into focus the idea that water floats. And I know I've brought it up a lot. When I stop and think about clouds, I'm still unbelievably mesmerized by the idea that upward lift and some kind of pressure can keep water floating at 10,000 feet or however high that is. So much so that it's considered a river when it opens up. And it's so heavy that when it comes down, it's like an inch an hour of rain covering, massive amounts of territory. So much water floating over our heads. And we just pass this all by calling them clouds. We don't even stop to say to ourselves, how does it float? And what should we be learning from that? Because floating water rivers is just
legit. Yeah, we actually, to answer your original question, we actually had over the last 48 hours, it ended about 24 hours ago, about 24 hours, maybe 20 hours of really heavy rain. It just did not stop. I mean,
really?
it was a flash flood. Yeah. Roads were just almost impassable. And then it's gone, poof, like that.
Yep.
Weird.
Yeah, and somehow the water then shows up somewhere else and floats back up into the air as vapor, and then all gets together and floats around up there. We're going to get a meteorologist on here one of these days. Hey,
you
tell us
that from school,
Yeah. And we, again, it's just the stuff we just say like it's just common fact. Like, oh, here's how it works, and you stop and think about it for a minute.
It's right amazing. Up there with electricity, which still just seems like magic to me.
It is. I teach electricity and magnetism, and it still seems like magic to me.
So okay. So Paul, well, let's invite people to put in the chat whether you're on YouTube, which is our preference for you to watch this, or if you're over on Facebook or Twitch or Twitter or any of those places. Let us know what the weather's like in your place, and what's happened there. All right, Paul. So I know we're going to talk about space, but you teach electricity. I'd forgotten this. Talking about like. Not if you're at a college level teaching like you normally do with the students here at St. Agnes. Let's say you were invited into an 8th grade science class to tell the kids about how electricity works. They treat Dan and I like 8th graders.
It's generous, but
when I plug a plug in with my little metal prongs, and it's apparently inside of that plug is touching other metal prongs, it then starts to draw energy, electricity.
Draws charge,
Draws.
All those things, yes.
Okay. Didn't know they were different. Is it Is the charge, the electricity just sitting there, or is it running through something, or like how is it ready to just constantly start coming the moment I plug it in there? Like what?
Think of it like a river. We were just talking about rivers overhead. Now we're going to talk about rivers in your wires.
Oh my gosh. Okay.
If you've got a lamp and you look at the cord, there's two wires inside that cord.
Yep.
Think of them as one wire going and one wire coming. It's like when you plug that into the outlet, it completes a loop. It's like water in a pipe. Okay.
Got it.
You got two pipes. Okay. And those two pipes there's really just one pipe, right? Because they go up to the lamp, and then the pipe runs up to the lamp, to the light bulb, and then runs back down the other wire.
Okay.
So when you plug that into the wall, you're completing a circuit. So the water can, in a sense, flow through the pipe. But the water is electrons. It's not obviously water. You're completing a loop.
And the electrons are just sitting there.
Yep.
Because the thing about, when you think about water flowing, which is kind of the imagery I have in my head, the water would like, I guess same with my water coming in the house. It's like backed up or sitting at a stopper.
Yeah, right. So
is electricity sitting at are those electrons
just sitting there? Electrons are just sitting there. Now, remember, that doesn't mean that your wire has a negative charge, because there's there's equal number of protons in the wire too. So the wire is neutral. Okay. But here's the point. The electrons move and the protons don't.
Okay, one more time on that. The electrons move and the protons don't.
So when you plug in your lamp and that current starts up, it is electrons that are moving.
Okay.
They're flowing down the wire. They're right there waiting to start moving. And when you plug in the wire, all of a sudden there's a complete circuit, and they can move. Any section of the wire, and the wire itself is electrically neutral, right? It's not charged up. Any section of the wire, just imagine an inch of the wire. Mm-hmm. It has no net charge. There are as many protons in that section of wire as there are electrons. But when you plug your wire in, the electrons are moving. And so, yes, the electrons are right there ready to move when you plug the lamp in. And when you do, they finally have a complete circuit through which to flow. But until you do that, they can't go anywhere because there's nowhere to go.
So they're actual. It does. So they're actual little things. Obviously, electrons are moving around. They take up some sort of mass, like water takes up volume. So when a
little bit of mass, not much, but a little bit.
So when a generator or a power plant produces a bunch of electricity and sends it out through transmitters, and then it runs into a wire that comes into my house, and then all the little wires run to all my outlets and light bulb sockets. Mm-hmm. The electricity is just sort of sitting there. It doesn't really back up like water. Like what?
I wouldn't use the word electricity. I'd use the word electrons, because they're physical, discrete objects, electrons that are sitting there. Yeah. And they're not backed up. No, they have a sort of they're not backed up. They're not all piled up there, ready to burst through.
More aren't coming.
There's plenty behind them, but they have basically a uniform density throughout the wire. They're not all piled up in one place.
Okay.
But they have nowhere to go until you plug it in, and then if you go to a pool and they have like the river that goes around and around, one of those big public pools. Yeah,
like the lazy river.
It's like, what if you just dammed that up? The water would just stop. And then once you open the dam up and complete the circuit, they'll start to move again.
Well, I know that's all true. It just still bends my mind. It's
just still magic.
Yeah, still ultimately magic. All right, well, let's chat about what happened in space in 2022. This nice little article came out and said, hey, we had a good space year, a good solid space year. So Paul, you're an astrophysicist, and good on your people, your
Thanks,
crowd, your industry. It's doing pretty well. I mean, it seems like you've shaken off that what was looking like it was going to increasingly be the work of space owned and conceived in most people's minds to be just the project of Elon Musk. That seems to have shifted now that he cares about much more important things. And boy, there's so much happening that this little recap that we saw in the news really widens the eyes as to what's going on up in the up in the sky. I mean, first and foremost is, of course, the James Webb telescope that they finally got up there and has done nothing but seem to deliver for people who care about that stuff. The people who wanted the James Webb to be good.
And as we've said before, there's nothing like when in a world of chaos, there's nothing like something working.
Yeah.
Just
good point. Good point.
What a relief. What a hopeful thing to see us do something that actually works.
So this little article says it's difficult to imagine a more hyped up moment for NASA in the last number of years than the photos from the James Webb telescope. Billed as the successor to the iconic Hubble Space Telescope, the $10 billion observatory was launched into space on Christmas Day in 2021. Just so great. It was designed to study to study the early days of the universe when stars first flickered on in the cosmos. So when someone, I don't know, I guess completed a loop and stars started doing whatever they do, that's what they're trying to look at. Pretty impressive, huh?
Yep.
Now, Paul, people will say, and I'm sure people listening right now, I know one of them, married to her, will say inside or maybe mumble silently, $10 billion is so much money. And there's a lot of this energy that goes into why are we spending so much money on space and so much money on this and the $500 million and $300 million and $10 billion, which, by the way, $10 billion over like 20 years, right? I mean, I think it took they spent that money over.
We didn't spend it all last year, right?
Yeah, it wasn't all on Christmas Day. It wasn't there was not a big credit card bill for $10 billion. But here's a little fact for people that are bothered by such things. Did you know that in the United States of America, every year we spend $7 billion on potato chips alone? Just potato chips, not potato fries, not skillet fries, not corn chips, not those terracotta chips. They're not even included. $7 billion on potato chips.
So this is not just snack chips in general. This is like those old basic Lay's potato chips that are just literally sliced potatoes.
The ones, in the yellow bag that are made from potatoes. Now that means that that adds up to 2.4 billion pounds of potato chips a year. 2.4 billion pounds. It's about 12 million pounds of potato chips are eaten on the Super Bowl Sunday.
Wow.
12. So here's why I bring this up. Because when you only hear certain numbers, like the Congress wants to spend $1.9 trillion over a 20-year budget, or $10 billion for the space telescope, or $1 billion to send a private rocket up to somewhere, people are like, that's all the money. I mean, this is the emotional response people have.
Right.
Now we can't do other things like help people or solve for cancer or figure out how water floats because we spent all our money on that dumb thing that nobody. Until you realize there's so much money, like the scale at which America spends money. Almost as much in 1 year on simply potato chips is spent of what it took, like 70% of the Hubble spacecraft that took 25 years.
Right.
So in those 25 years, I can't even do the math. I don't know what 7 times 25 is. It's a hey Siri, what's 7 times 25?
It's 175.
How do you know that's so fast? It's $175 billion have been spent on potato chips in the amount of time we spent on the Hubble space. 175 billion instead of 10 billion, just on the potato chips.
It reminds me of the people that are like, well, millennials, if you would just give up your latte each day, you could save
avocado
for
toast.
A house. Yeah.
But if all the millennials chipped in together, they could all buy one house if they gave up their lattes. Right. That would be enough.
Yeah.
You know.
But if all Americans gave up our potato chips, we could buy another telescope. Sounds
right.
Like.
Yeah, well, in just 1 year, you could buy a whole telescope for for the next 30 years of.
If you just give up, which aren't even good for you, they're bad for you. I mean, make
potato
America
chips.
healthier, and also buy a new Webb telescope every year.
Every year, just on the potato.
Every year.
If you threw in corn chips, I mean, I don't know why I didn't look this up. I bet even more money is spent on corn chips. I mean, more money may be spent on hot Cheetos.
Yeah.
Now that marijuana is legalized, there could be more money spent on hot Cheetos than there is on all the rest of this. So putting it in scale, a government agency like NASA spending money over a 20-year period of time to accomplish the scientific discoveries of $10 billion. Let's not freak out and have all the conversation be about why are we spending all of our money up there and wasting it, because it's not that much money. It's actually a teeny amount of money compared to what's spent in the United States on everything, on all the things.
It's not an either or question. I mean, it's really not. It's not like we don't have enough money it's a matter of will. Are we going to make people's lives better or not? Are we going to help alleviate poverty? We're going to help people who really need it and need help. Or, it's not that or Webb.
Yeah.
It really is not. It's a question of our will.
Yes.
Not of how much money.
Yeah. And the scale of dollars that you're talking about in an economy as large as the United States, and that's just in the United States, right? That doesn't even include all the Canadians who I think eat a lot of potato chips. So there's so much volume of money spent on so many things that a lot of people have a hard time, and they've been having this hard time since we've had the space endeavors, people saying, let's go to space. This constant conversation about should our money be being spent on that while, people on Earth are struggling is one that it's perennial. Like it's not going to go away because of a factoid about potato chips, of course. But it is just good to know that we do have the capacity to accomplish all these things. And other spending as well. Frankly, other government spending, when people are like, we spend X amount of dollars, I know. You start totaling up all the money we spend on all the things. It's insane.
Mm-hmm. Yeah. And also, because in our daily lives, we all deal with, a lot of money to us on a daily basis is $1,000. It's like you get, we deal with thousands and $10,000s of dollars for big. That's a lot of money in our daily households, and we see $1 billion, and it is sort of a failure of imagination to see how things scale up when you start talking about 330 million Americans.
Yeah, it's just hard for the human brain to comprehend these numbers.
It's not possible. It's like trying to imagine even the size of the solar system, which I can't do.
Right.
I can't even imagine that.
Trying to imagine these images from the James Webb. We've got on the screen. We've got they picked out a random star, pointed the telescope at it, and then it reveals like multiple potential exoplanets.
Yeah.
Within that, you keep zooming in, and you realize a pinprick in the sky is a galaxy full of billions of stars.
Yeah.
With billions of planets.
And my mind fails way before we get anywhere close to that star.
Yeah, right.
And I've been trying to imagine this my whole life, like on purpose,
Yeah.
and
On purpose.
That's right.
I can't do it. I mean, I guess what I'm saying is I can imagine like the size of the solar system compared to the distance to the closest star. I can kind of imagine that, but I can't get it all in my head at the same time.
Mm-hmm.
I can compare one thing to another, but I can't compare the size of the solar system to, the distance to the length of my commute, daily commute.
Yes.
My brain, my imagination is not capable of visualizing the scale of the solar system compared to my normal daily scale of distance.
Paul, I won't take us down this road for too long here, but if you we've tried this before, but if you could walk me through again, why does a telescope like the James Webb, why do they say we're going to point this laser telescope thing, draw in radiation light that comes into the sensor on the telescope? How is it that is described as looking back in time to the origins of the formation of the universe?
Okay.
Why is it said I'm looking back in time? When I look through another telescope, I don't know, across the land or the ocean, I'm not looking back in time.
Yeah, you are.
Really?
Yeah. When you look across the room, say you're giving a public talk and you're up on stage and you're looking out at the people.
Yes. And
you are seeing the people as they were a few nanoseconds before the light actually enters your eye. Because it took a few nanoseconds for the light bouncing off of them and travel through space from their noses to you, to you. It took a few nanoseconds. So you're seeing them as they were.
But if I took a pair of binoculars or a telescope and looked at those people, would that light be hitting that sensor any sooner?
No.
So why am I looking? How does the telescope help me solve that light bounce problem?
So do you see how when you look out and see those people, it took a few nanoseconds for that light to reach you?
Yeah.
Okay. Now let's now go somewhere else. Go out on a boat and look through either with your unaided eye or with a telescope. Doesn't make any difference.
Okay.
You look a few miles away to an island.
Okay.
You're seeing that island as it was maybe a couple microseconds before.
Mm-hmm.
Because it's now taking several microseconds for that light to travel. When you look at the moon, that light took about 2 seconds to travel to you.
Okay.
So you're seeing the moon not as it is when you see it, but as it was 2 seconds before you see it.
Okay.
Now keep extrapolating that out and out and out and out and out. The sun is, you see it as it was 8 minutes ago.
Okay.
The closest stars you see as they were maybe 4 years ago. The closest stars. Okay. The center of our galaxy, you're seeing as it was 27,000 years ago. Because that light is now not taking a nanosecond or a microsecond or 2 seconds. It's now taking years. And for the center of our galaxy, it's taking about 27,000 years.
Okay.
So you're seeing it as it was 27,000 years ago, and keep on pushing that back out to the nearest galaxies. You're seeing the nearest major galaxy as it was 2 million years ago.
Wow.
That's the nearest major galaxy, 2.4 million years ago. And then on out across the sea of galaxies to the earliest moments of the universe, 13.8 billion years ago.
Mm-hmm.
Do you follow? So
I am. Yeah. It's just, it's some point, I don't know, between the telescope on the ocean and it just becomes another one of these mind benders.
You get the principle.
I do. I get the principle.
You get the principle. And so when you go out at night and look up at the sky, you're seeing every star as it was at a different time in the past.
Mm-hmm.
Depending on its distance.
And so if one blinks out, we won't know for dozens of years, millions of years.
If the closest star to us blinks out tonight, we won't know it for 4.2 years.
But the sun would take us, what would you say, 8 seconds?
8 minutes. So if the sun were to go out right now, we still have 8 minutes and 19 seconds we wouldn't know it. We couldn't know it. We would have no idea that it happened until 8 minutes and 19 seconds later. Everything would be totally normal, including gravity.
Wow. So if you tend to worry about things and think, I wonder if the sun just went out, wait 8 minutes and 10 seconds, and then you'll know it didn't.
Something.
It didn't 8 minutes ago, but they could in 8 minutes. 8 minutes now. You just don't know. You don't know what's sneaking up on you. All right. Well, that's so. Why is that a big thing for when people say now we can look back and see the origins of the universe? That's the part I guess that it's. Just,
I guess the thing
correlation
is that if you happen to be interested in the origins of the universe, we're in luck. Yeah. Because the way the universe works is that we can actually look, if we have a good enough telescope, we can look back and see it. Just because, and the only reason that we need James Webb to see it and telescopes like it is because they're sensitive enough. Because these objects are very faint because they're very far away.
Yeah.
And so
are they only in? So when they're saying we're gonna look back to the origins of the universe, this concept, right, and we're gonna see things and discover things, and so I believe that's what they're doing. It's just hard for me to wrap my mind about how it works. Can they look in every direction and see the same thing, or do they have to look in one? Like, did this telescope, for any reason other than being, protected from the sun's rays and the
it depends on what you're looking for. If you're looking for a particular galaxy, of course, you have to look in the direction of that galaxy. But the general nature of the universe, the general appearance of the universe is the same in every direction. We don't.
How can that be?
In other words, we don't have to look back in a certain direction to see the Big Bang.
Wow.
To see the echo of the Big Bang. It's coming from all directions equally.
Does that make sense to you? Is that one of those things?
It makes sense to me, but it's not. It does not make sense on the face of it. And it goes back to the same thing I've said before, but I will say again because it's such a common misconception. That it is not as if the Big Bang was not like this. It was not as if there was all this empty space sitting around waiting for something to happen.
Yeah. And
then, boom, this Big Bang happened at some point. Because people think we have to look back to some point in space to see that. But it was not that way. Because there was no empty space waiting around for something to happen. Space itself was wrapped up in the Big Bang and was created at the same moment that everything else was created. So in a sense, the Big Bang happened everywhere. Because all space was at that point of the Big. All space was wrapped up in that point. And has been expanding ever since. So there's really no center.
Now, I know this is what the scientists tell us, but I'm going to have to do my own research on this. I'm just going to have to.
Well, there's a couple of great YouTube videos. I got to point out.
Okay, yeah, great.
It's just easier if the Earth is flat and
I just do my own research.
Rain is pretend.
All right. Well, the James Webb, obviously one of the great things, and I care about this stuff and really think about it, and it still just bends my mind. Another big story here is the trying to move asteroids, trying to bump asteroids, like in that movie Asteroid. And apparently they accomplished this too. They were able to shoot a rocket for a mere $325 million. I mean, basically, a couple of Sundays of potato chips.
couple of football games.
And like end of the regular season Sunday, not Super Bowl Sunday. And they nudged an asteroid to alter its trajectory enough that if they think they could figure out a big one's coming at Earth, maybe they could bump it away.
Yeah. Which is
this just doesn't seem necessary to me, but yeah.
Well, it doesn't seem necessary, but if let me tell you, Doug, if you go look at NASA's list of near Earth objects.
It'll make it necessary.
Yeah, and if you spend some time meditating on that, on that spreadsheet they've got there, you might start to see the wisdom of it. It is a matter of time. It's not a matter of if, it's a matter of when. Now, probably not this week. You're probably safe next Tuesday.
Next 8 minutes or so, or
but it is going to eventually happen.
Huh. Yeah, it's just a matter of how big the object is, and
I mean,
don't they have a map?
They hit the Earth all the time.
Yeah, that's what I was going to say.
Big, and it's a matter of statistics. I mean, there's just a lot more small ones than there are. It's like cities on a map. There's a lot more small ones than there are big ones, but there are definitely big ones, and it is a matter of time. No question. Wow.
Yeah, so
they feel
when I was a kid, I remember when I learned about the dinosaurs being killed. I was like, so what killed them, right? And then I learned, I read Carl Sagan's Cosmos, and I was like, they were killed, by a rock from outer space.
Yeah, it's
like, as like a 10-year-old.
Yep.
You're like, oh, well, when's the next one?
Yeah.
By the way, have they found that remnant of that asteroid that hit the Earth and caused the big dust plume?
Yeah, they found. They're pretty confident that they found the crater. Yeah, it's basically it's half of it. It's half of the Yucatan Peninsula. Basically, it's right off the Yucatan.
Really,
half of it's underwater and half of it's on the peninsula itself. Yeah.
Yeah, like vacation parts of Mexico that you're talking about.
Exactly. Yeah, Belize. No, it's on the western side. So I guess that's actually Mexico. Huh. It's on the western side of the peninsula. Yeah. So half of it's in the under the water in the Gulf, and half of it's on land. But it's got the right size. It's got the right date, and so forth and so on.
And again, when that, to remind us, of 7th grade geology, that thing hits and puts up such a plume of dust and smoke and everything that it basically
takes 10,000 years to settle.
And that brings on the Ice Age. That's right. That's what
it basically cuts the solar. Basically, imagine the most overcast day you can imagine. Multiply that by 10, and then let that last for 10,000 years.
Why did that kill all the dinosaurs? Seriously, like why?
It didn't kill all of them.
Right.
It just killed the largest ones. The smaller dinosaurs mostly turned into birds, which is another reason why I love birds so much.
Well, they're not real either. That's really.
Birds aren't real.
That's part of the reason you don't that you're into birds. You're like, they're just little survivors. Those little
they're survivors, man. They're not. Yeah, they're not. They're basically reptiles. Mm-hmm. They're basically they're basically the dinosaurs that didn't die.
Huh.
Yeah. Which is
I was listening to another podcast about the Loch Ness Monster. It was a podcast where the topic was about
we're getting somewhere.
Yeah. So it's not about Loch Ness Monster, and it's a podcast called Stuff You Should Know, and this is one particular episode. Anyway, they were talking about the Loch Ness, where the Loch, where where the people say they see this Nessie monster thing. And that Loch is only 10,000 years old. Like the Ice Age, pullback, like a big ice carved it out 10,000 years ago. Like that is not very many years ago.
That's almost within written history, recorded history. Yeah, we have ancient art, cave art that's way older than that.
Yeah.
Yeah. It's really, so the hangover of the Ice Age was a really long time on Earth, I guess.
All those lakes in Minnesota, same thing, right?
I guess I don't. I haven't really done the math on how old everything is.
Yeah, Minnesota was covered in glaciers 10,000 years ago, 15,000 years ago,
and apparently again today because there's 15 inches of snow out here. We're back to the Ice Age,
and woolly mammoths. Mammoths were everywhere. Yeah. Not everywhere, but they were
trouncing around.
Trouncing. It is something because, again, you start just doing some basic math, which apparently you're better at because you got 25 times 7 to 175 without even batting an eye. You didn't even have to ask Siri. If you go back 2,500 years or 3,000 years, it's a long time, but we have like history of that time, and people, you find stuff that was sort of around and little civilizations. Well, 10,000 years ago, there was nothing. It was like,
they're actually discovering more and more every year. Like the stuff that survives that long is limited. You get some human skeletons, but you also get like mounds and like rock formations from back then, like end of the Ice Age and into the Ice Age even.
Yeah.
It's pretty trippy.
Yeah.
It is trippy.
I guess Stonehenge is what, 4,000 or 5,000 years old, something like that. So like Stonehenge just go back that amount of time, just that much time again.
Yeah, and there was nothing, like no recorded human history. Everything we know and have from any of that is all the last few seconds of the total clock of this thing.
Right.
Which is really I think for people who say things like, look, climate change can't be human caused because you can't see that amount of change that quickly. I don't know. The whole human project, as we sort of know it, is like 10,000 years, 10,000 years old, and we've only had industrialization really, for the last maybe 200 years, depending on how you count. 150 years.
Have you seen that article from is it 1913 or something? Some newspaper article basically where they're saying, oh, by the way, we're dumping a lot of carbon dioxide into the air, and that warms things up, and we might feel this in a few centuries.
And here we are.
Literally, yeah. It's like, well, yeah.
Yep.
No, it absolutely could change that fast.
Yep. Seems like it is. Do you think this, and this is one of the topics in this article, but do you think this fusion success that happened, sort of confirmed?
I think it's awesome. I think any step in any real genuine step in direction of controlling fusion is phenomenal, because if we are able to get that controlled and get it channeled in the right direction, that would solve so many problems. It is worth putting money into that.
Yes, it just seems like the whole ball game. Put all the chips on,
put all
Fusion
chips.
7. Put all our 7 billion potato chips on.
It's clean. It has absolutely zero waste products that are damaging or harmful to the environment. It's not like fusion that can have this kind of runaway kind of problem, like what happened, with, this sort of Chernobyl kind of thing. That a threat of that sort of thing is absolutely impossible with fusion.
So fusion doesn't have the nuclear power limitations or fears.
It is nuclear, but there's no waste from it, and there's no chance of a runaway reaction from it, like there is with fusion. I mean, like there is with fission. It's just, and there's none of this nasty stuff you got to bury in the bottom of mountains, for 20,000 years, no stuff like that. No contaminated groundwater, nothing like that.
Right. You're welcome, Utah. Finally, we're gonna get to make sure you don't have to bury all the waste in Utah.
Yeah.
That really does feel. Did some of that come from all these same projects, all this same going to space and nuclear needs to get to space and all that? Was that fusion success connected to all this?
There might have been some spin-offs that went, in a certain direction, but I think mostly no. It's more or less an independent.
I guess in my mind, somehow the nuclear movement from the 1950s and power plants and all that stuff and the space race feels like they were all that was all one kind of motion, and I've wondered if
there have been nuclear powered probes, just like as there are nuclear powered submarines, but those are all based on fission reactions.
Mm-hmm.
Heavy elements like plutonium and uranium, things like that. Yeah. Whereas fission is basically, water. I mean, fusion is basically, just hydrogen, water.
It's incredible. Do you remember back in the early 2000s, even before September 11th, I think, when Bush gave his first one of those, like, hey, here's the future of the country, and laid out this, like, in the next number of years, we're going to see hydrogen and fusion. Like that was the big goal, to fund all that stuff.
Oh yeah, it's been a big goal for. There's a joke actually among physics people.
Can't wait to hear a physics joke.
It's really not funny. Don't get your hopes up. But it's just this long-standing joke that solving fusion is like 30 years away. Always. Yeah. So 30 years ago, when I was in graduate school in the early 90s, 30 years away.
Yeah. Hey, maybe they were right at that point, because here we are.
Maybe they were. Yeah. Now the thing that happened, as I understand it, is far from having fusion plants down the street,
right?
Like we have coal plants now down the street, but it is a distinct step forward. It is a notable, it's one of these steps you have to pass in order to get there, and it's a big one.
They made
there are many more.
There are
many more, but it's a really hopeful sign.
Yeah. You know what else is exciting? Getting back to the moon.
Hey, I like it.
Back it up, baby.
I'm excited about this. We did a little test run this year where we sent an unmanned mission, flew it around, brought it back in preparation for a human mission to the moon, and I guess it's a couple years out still.
Because I wish it wasn't. I wish they would. And I remember we talked about this a few weeks ago, about why the delay. And I think it's unfortunate, because I really feel like to get the public behind it, you kind of have to make a little bit of you have to tell a story and sort of put on a show, not in the sense of, dog and pony show, but in the sense of you need to make it a story. You need to give it a little drama. You need to, and I feel like a 2 or 3 year lag is going to be tough.
And back in the Apollo days, they were doing missions, sometimes a couple a year.
Right. Exactly.
Months turnaround in between, but they kept the tempo going.
Yeah.
It's a little frustrating that they can't.
And other countries are doing this. This article goes on and talks about how South Korea has a private industry that's doing it, a number of other private industries. If they can just sort of put all that together into a human project of moon visiting.
Yeah, the more nations that get together, the better, in my mind.
Mm-hmm.
Yeah. This a couple weeks ago when we were chatting, Dan mentioned this podcast called 13 Minutes to the Moon. And I started listening to it. And one of the guys the person who flew the other spacecraft around the moon while, the two guys landed on the moon, hit golf balls.
Yeah.
He, I think that's who they were talking to. And he said, when we got back from the moon, we thought this was going to be a big space race, like the United States put a man and walked on the moon. He said, as it turned out, the entire world felt like humanity had accomplished something. Yes, it was competitive between the U.S. and the Soviets, but everyone was like, humanity has now crossed a precipice and has accomplished something.
Right.
That feels like what we need again.
Yeah, that's not America. That's us. That's everybody.
Yeah, and maybe it's because what Neil Armstrong said. It's one small step for a man and a giant leap for mankind, or something. Like maybe it was postured that way, or maybe he was tapping into what everyone sort of felt.
Yeah,
that would be great if our